Okay, so in this video, it is on on Unit 7 review. It's going to cover everything that we've covered in Unit 7 that's going to be on our tests. So there's no handout with this. After this video, you will work on your study guides, Part 1 and Part 2, and everything that's going to be on the test will be on that study guide. There will be no surprises if you can do all those, answer all those questions, work all those problems, and know the definitions of those words on the study guide. You should do really well on the test. Now, one thing that I'm leaving off of this test is limiting reactants. We just had a quiz last Friday on that, and since I quizzed you on that, and those problems are are long to work, and I want to make sure you get this test done within a 50-minute class period, I'm going to leave that off of the Unit 7 test. But what you need to know is you need to know how to calculate molar mass, which you have to be able to do that to solve these problems, but there might be a couple questions on the test where it just asks for the molar mass. You also know how to convert moles to grams, which we know how to do that. You multiply by the molar mass. We've been doing that for a while now. Converting grams to moles, you divide by the molar mass. Take your grams that are given, find your molar mass of the substance, and divide by that molar mass. We need to know mole-to-mole stoichiometry problems. Those are our one-step problems. Moles to gram stoichiometry. If you start off in moles and you have to find your answer in grams, that was a two-step problem. And then we need to go grams to gram stoichiometry. That's our three-step problems. And then finally, percent yield. Those will be the problems on the test will be those top. Now we're going to look at like one example of each. It's a real quick video. If you want to write down, this stuff, if you can keep up and write down notes, or you can go back and watch this as you're studying if you need to, or especially if you're having trouble with this material, you really need to watch this video, or otherwise you might not do very well on the test if you're lost. Now, first I want to find the molar mass of MgNO32. Now, how do I do that? Well, I have one atom of Mg. I have Mg. I got one atom of it. I have nitrogen. How many atoms I have of that? Well, I got one on the inside of the parentheses, and that multiplies by the number on the outside of the parentheses. So 1 times 2, I got 2 nitrogens. And then oxygen, I have 3 on the inside times 2. Oxygen, I would have a total of 6. Now, if I extended this formula out and took out the parentheses, that would be MgN2O6. You can always do that. Just extend it out, and then you have your number of atoms right there. So magnesium, I need to multiply them by the molar mass. If I look at the atomic mass on the periodic table, that's what's beneath the symbol, the number that has a decimal on around these two decimal places. If I look that up for magnesium, it would be 24.31. And for nitrogen, it would be 14.01. It's on around two decimal places. And then oxygen would be 16.00. So when I work all these out, 1 times 24.31 is 24.31. 2 times 14.08 would be 28.02. And then 6 times 16, bring my calculator, equals 96.00. So I add all these together to get my total molar mass. That's 24.31 plus 28.02 plus 96. I get 148.33, and that's going to be grams per mole because that's the units for molar mass. Now, my next question is this: how many grams is 0.35 moles of magnesium nitrate? Well, I've already found the molar mass, so remember to go from moles to grams, I multiply by the molar mass. So I take 0.35, multiply it by the molar mass I've calculated, 148.33. And I get around this two decimal places, 51.92. And then my units would be grams of MgNO32. My next problem says how many moles is 800 grams of MgNO302. When I go from grams, if I'm going from grams to moles, I divide by the molar mass, but I take what's in the problem first, the grams given, that would be 800, divided by the molar mass, which is 148.33. And that would give me 5.39. That's 2 decimal places, 5.39. My units would be moles. And then my substance is MgNO3, which is magnesium nitrate. You have to understand how to do this right here to be able to do stoichiometry problems. Now, if we look at next, mole-to-mole stoichiometry, these are our one-step problems. All right? We do not have to convert to grams or convert to moles in the beginning. We're already in moles. We're going from moles of one substance to moles of another substance. So it's asking me how many moles of H2 are produced from 1.4 moles of HCl. So I'm given 1.4 moles of HCl. And so I'm given 1.4 moles of HCl, and I'm trying to go to moles of H2 that would be, produced from that. All right, well, the balanced equation tells me moles. It tells me that at the most basic whole number ratio, the simplest reduced down whole number ratio, the way this thing is, every time 2 moles of aluminum react, it reacts with 6 moles of HCl, and the products are 2 moles of AlCl3 and 3 moles of H2. So my balanced equation tells me that whenever 6 moles of HCl react, I get 3 moles of H2. All right, it's a 6-to-3 ratio, which is also a 2-to-1. All right, but I don't have 6 moles. What I have is 1.4 moles. So the way I set that up is I'm going to take the coefficient that's in front of there of the HCl, which is 6. That'll be 6 over how many moles I actually have, which is 1.4, equals the number of moles in the balanced equation for H2 is 3, and I put what I'm looking for is moles of H2 that's produced from 1.4 moles, so that'd be X. Right, at this point, I'm going to simply cross multiply. That would be 6 times X equals 6X equals, and then so that would be 3 times 1.4 would equal 4.2. Divide both sides by 6 to solve for X. My answer, X is 0.7, and my units now, I went from moles of HCl to moles of H2. That's a one-step problem using the balanced equation, the coefficients to do that. Now I showed you another way to do that earlier in the when we started working these mole-to-mole stoichiometry problems. I showed you 2 different ways of doing this. You can do it either way. I know that most of you are probably doing it this way right here though, and that's why I'm working them out this way. All right, next, grams to gram stoichiometry are 3-step problems. All right, and those steps are, first, you take the grams that are given to you in the problem. That's your starting substance, whether it's a product or a reactant, doesn't matter. And you convert that to moles. And the way you do that is by dividing by the molar mass. Next, once you've done that, now you're in moles that are given. You went from grams given, your starting substance, to moles given, which is your moles of your starting substance. And you want to go to the moles of what you want, which is the new substance. And you do that by using the coefficients in the balanced equation. You have to use those coefficients as the only way you can go from the amount of one substance to the amount of a totally different substance. Once you're in moles of your new substance or moles that you want, you convert that into grams of the new substance, and you do that by multiplying by the molar mass. Now, when we do mole-to-mole stoichiometry, we only do step 2. Step one's already done for us, and we don't have to do step three. When we do gram stoichiometry, we have to do every step. But how about if we were given moles as a starting substance instead of grams? Well, if that was the case, we wouldn't have to do step number one. We'd only have to do step number 2 and 3. I told you earlier when we did videos that someone could write these steps down on the board where you could see those. I don't mind if you do that while we have a test. Just these 3 steps right here for gram to gram stoichiometry. Now, so if we look at a gram to gram stoichiometry, the first thing we always do before working any of these problems is to make sure we have a balanced equation. Now, I've not made you balance any much in this unit just because that takes a lot longer to work the problems, and on the test you won't have to balance any. But just always check and make sure. Now, we want to know what type of stoichiometry problem is this. Well, it says how many grams of HCl, that's what I'm looking for, reacted to produce 56 grams of AlCl3. So what it's saying is that this reaction happened theoretically. If we get 56 grams of this, like say if we wanted 56 grams of AlCl3 in a reaction, we would need to figure out how many grams of HCl that we need to react to get that. That's a grams to grams. That is a 3-step problem. So to go through those 3 steps, my first step is I want to go from grams of given in the problem. So I want to go from grams of AlCl3 to moles of AlCl3. The way I do that is I take the grams that are given to me in the problem. That would be 56 divided by the molar mass of AlCl3, which I've already calculated. You'll have to calculate the molar masses on these problems, but I've already done that. It's 133.34. So I have to work that out my calculator first. I'm going to round this to 2 decimal places. Always round everything 2 decimal places except the percent yield problems. So it'll be 56 divided by 133.34. And that gives me 0.42. 0.42. Now my units are moles of my starting substance, or my given, which is moles of AlCl3. Alright, so my next step is I want to go from moles of AlCl3 to moles of my new substance, which what I'm looking for is HCl, so I got to go to moles of HCl. I do that using my balanced equation. Now, remember in this problem, I got moles of AlCl3. So I look at the coefficient that's in front of AlCl3, which is a 2. So I'm going to put 2 over how many moles I actually have, which is 0.42, equals, and I'm going to moles of HCl. So I look at the coefficient in front of HCl, which is a 6. So that'd be 6 over X. So what I'm saying is every time 2 moles of AlCl3 are produced, 6 moles reacted. Well, how about if 0.42 moles were produced? I want to know, and X is going to tell me how many moles of HCl reacted to get 0.42 moles of that. So when I get to this point, I'm simply going to cross multiply, and that would be 2x equals 0.42 times 6 equals 2.52. Then I divide both sides by 2. And my x is going to be 1.26. And I went from moles of AlCl3, now I'm in moles of HCl. But I can't quit because it wants the answer in grams. So then I'm simply going to convert 1.26 moles of HCl to grams. So I take 1.26, I have to multiply it by the molar mass of HCl. I've already calculated that. It is 36.46. And I get 45.94 and my units would be grams of HCl. So theoretically, on paper, to produce 56 grams of AlCl3, I would need to start with 45.94 grams of HCl. That's what I've calculated on paper. Now my next problem though, I'm going to use the same, balanced equation to work these. Now it asked me how many grams of H2, that's what I'm looking for, will we produce from the reaction of 6.2 moles of Al. So if you notice what I'm given in this problem, I'm given 6.2 moles of Al, and I'm asked to go to grams of H2. So this is not a three-step problem because I'm given moles to begin with. So basically I can skip that first step. That first step, when I convert grams to moles of my given, I can totally skip it and go to step number 2 because I'm already in moles. So I go to step number 2, which goes, which I'm going to convert moles of Al, and I'm going to go to moles of what I'm looking for, or the substance I'm looking for, which is H2. So I use my balanced equation for this. All right, so I have 6.2 moles of aluminum, but I looked about the coefficient in front of aluminum, which is a 2. So I put a 2 over how many moles I actually have, which is 6.2, equals, and then I'm going to H2. So I look at the coefficient for H2, which is a 3. That'll be 3 over what I'm looking for, which is X. I'm going to cross multiply, and I get 2X equals, and that would be 6.2 times 3, which equals 18.6. Divide both sides by 2, and your X is going to be 9.3. And what I went from moles of Al, now I'm in moles of H2, which is my new substance. My last step then simply is to convert to grams. I got 9.3 moles of H2. I want to multiply by the molar mass of H2. Now the molar mass of hydrogen is 1.01, so H2 would be 2 times that, which would be 2.02. That would get 18.79. And that would be grams of H2. So this would be a two-step problem because I was given moles in the beginning, so I could skip my first step out of my 3 steps. So basically what this says is that if I start off with 6.2 moles of Al, I should be able to get, theoretically, my theoretical yield would be 18.79 grams of H2 produced. Again, remember, if we're calculating the mass of a product that's produced from a reactant, we call that the theoretical yield. Okay, next problem. If we're talking about percent yield is equal to actual yield divided by theoretical yield times 100. Well, my percent yield tells me how efficient a reaction is. My actual yield should always be lower than my theoretical yield. My actual yield is what I get when I go and actually do the experiment in the lab. My theoretical yield is what I calculate on paper. That's why it's in theory. That's how much I should get. And these are, on paper, and they are calculations. So these stoichiometry problems we've done, if we're calculating the mass of a product, we're finding the theoretical yield of it that should be produced. All right, so and your actual yield should always be lower because of human error. And some reactions are just not as efficient. You're not going to get as much as you predict. It's kind of like when you're planning out your day. You plan out, every hour what you're going to do. If you're a lot of times you don't get as much done as you would plan out. If you plan on not having any distractions, and but then things come up, you don't get as much work done. So it's the same way with this types of reactions. Your actual yield, you don't never get as much as you calculate that you're going to get. But anyway, this problem tells me if the actual yield is 2.3 grams and the theoretical yield is 7.5 grams, what is the percent yield? My equation tells me the percent yield is equal to actual yield, which is 2.3, over my theoretical yield, which is 7.5. Divide first, then multiply by 100 to get a percent. So in my calculator, should be 30 points, or I can round these to one decimal place. I mean, just a whole number. So I can round that up to 31%. I got, in this problem, you got 31% of what you would have calculated you got. So my next type of problem, percent yield, it says if the percent yield is 88% and the theoretical yield is 10.2 grams, what is the actual yield? Well, if I start my equation, that's actual yield over theoretical yield times 100. My percent was 88, which equals my actual yield is what I'm looking for. So I'm going to put an X in there. I'm going to solve for X. X over my theoretical yield, it tells me it's 10.2 grams. And my theoretical yield and actual yield, you need to be in grams. They don't need to be in moles. Now, when I get to this, I'm going to solve for X. First, I'm going to divide both sides by 100. And that gives you 0.88 equals X over 10.2. To solve for X, I would multiply both sides by 10.2. When I do that, 0.88 times 10.2, I get 8.98. And that would be 8.98. And that will be grams, since I'm solving for my actual yield. And that makes sense, as it's lower than my theoretical yield. Now, my last type of problem that's going to be on this test, I'm not going to give you one where you have to find your theoretical yield through stoichiometry, that three-step, stoichiometry problem, like the very last one we worked on in the video and the notes the other day. We're not going to have one like that on the test. We're just going to have, like the ones I'm working right now and like the ones on the study guide that you're going to do. Basically, this says if the actual yield is 2 moles of H2O and the theoretical yield is 75 grams, what is the percent yield? So it's telling me my actual yield is 2 moles, and it tells me the substance. It has to tell me the substance is H2O. My theoretical yield is 75 grams of H2O, and the percent yield is my unknown. I cannot be in moles of H2O. I got to convert this to grams. So I take 2 moles of H2O. How do I convert that to grams? I multiply by the molar mass of H2O. Molar mass of H2O is 18.02. So when I plug that in my calculator, I get 36.04. That'd be grams. So then I'm plugging in my equation. Percent is equal to actual yield. My actual yield was 36.04 over my theoretical yield, which is 75, and multiply it by 100 to get a percent. So I'll do that, divided by 75 equals that, times 100. And it gives me a percent. I can round to a whole number, which is 48% would be the percent yield. All right, so if you could understand how to do all these problems that I just went over, and you can do the ones on the study guide, then you should be fine on this test. So now your assignment is to start on the study guide. You'll have time to finish tomorrow, and then, like I said, we'll have a test this Friday.